Well, we're moving right along, and in the last video we finished up our bearing covers. The last thing we need to do for our X mount is our stepper motor mount. So today we're going to start working on that. We're starting off with a 4x4 by 1/2 inch piece of aluminum. We're going to be boring. So this is what our stepper motor mount looks like. We've got our hole in the center for the shaft to go through. We've got this little recess for the stepper motor. We've got our 4 holes to mount the stepper motor. And we've got these holes to mount the plate into our spacer. These holes here, there's one on each side. And then on the back side we've got this little recess to give us some room for our coupling. So I'm going to get this piece of stock cut. We'll go out to the mill and we'll get started. Okay, I've cleaned up the edges on these two pieces, and now they are 4 inches by 4 inches, and this will be for our X-axis stepper and our Z-axis. Okay, so we've got our stepper mount laid out. I laid out for the 4 holes to mount the stepper, these 4 holes, and also the center. And we're just going to mill out the center hole and also this recess for the stepper to go into, and then we'll drill our 4 holes. Once we get that done, we'll flip it over and do the back side right here and get that recess. So let's get out to the mill and we'll start working on this. Okay, we've got our stock mounted in the vise, and I'm just going to center drill and then drill a 11/64 hole, and that should be good enough for our M5 by 8. Okay, I've got the boring bar set up in here with the boring bar holder, and I'm just going to progressively make this through hole bigger until I get to 32 millimeters. Alright, that's 31.45. That should be good enough. That's just the through hole for the shaft for the stepper and the coupling. Okay, next we're going to do this 73 millimeter recess right here, so that this will fit down inside it. This is 73.3 millimeters in diameter, and it's about 1.6 millimeters deep. Okay, I've moved this out in the center hole. I've left the boring bar in the center hole and I've moved it out, and I've got to get it out wide enough so that I can switch it into this outer hole. So in order to turn that big of a radius, I'm going to have to move the boring bar from the center hole to this outside hole, and then we'll have to adjust this back. Okay, we're done on this side, so I'm going to take this out. I'm going to double check all this, and we'll flip it over and we'll work on the back side. Okay, so I flipped it over and got it in the vise, and while we still have the boring bar set up in here, I'm going to relieve this area right here so that the coupling, if it needs to, it can slide down in there without any interference. Let's get started. Same as we've been doing, we're just going to take a little bit and then gradually work our way out until we get to the correct diameter. Okay, we're about 42. But you can see how the coupling will drop down in there, and I want to be able to get to the set screw. You see how it's in the end, so you got to have enough clearance if this goes down in there for you to be able to reach that set screw. So I need to go about 8 more millimeters. However, I'm about as far as I can go out here, so I'm going to move this boring bar to the outside hole and continue on. Okay, check that. Should be getting close. Again, this measurement's not critical. Alright, we're at 49.8. We're about 1 millimeter off. That should give me enough room to get in there and tighten that up if I need to. Okay, so I'm going to take this boring bar out, and I'm going to put my end mill in here, and we're going to come along and put that recess all the way around. It's going to be a 1/4 inch wide and 3/8 inch deep. Okay, so I've got my stock raised up. What I did was I just took a piece of cardboard and shimmed it up, and so now I have just literally a sheet of cardboard more than 3/8 of an inch, and I've set my depth, and you can see I've scribed my lines here, and we're just going to come over a 1/4 inch and put our step all the way around. So let's just do that. Okay, so I've just taken a scrap piece of 1/4 inch stock and just kind of checking it. And I think we're fairly close. So now I'm going to just take some measurements and we'll get it just right. And also check the fit with the square tubing. Alright, well, I'll clean this up with a little sandpaper. Cover fits on there real nice, like so. And now we need to, I want to tap these holes next. So I've got we're going to be using M5 by 0.8 screws, and I've got a M5 by 0.8 tap here. And I'm just going to run this down through here and tap these holes. Got a little tapping fluid here. This is just 2 parts kerosene, 1 part motor oil. Seems to work good for me. Tap these holes. That'll work. So I'm going to get the rest of these tapped and we'll be right back. Alright, so now that I have my holes threaded, what I want to do now is I want to make sure that my distances are going to be correct. Depending on what type couplings you get, they all vary in size, and even though I took the dimensions that they sent, you really never know how it's going to work out. These particular couplings are 40 millimeters long, and they go in about 23. Is that right? Let me double check. They go in about 20 millimeters on each side, but as you can see, it's not completely all the way through. And this shaft is 32 millimeters, so it's not going to go all the way down. So I kind of guesstimated on the length of my spacer, and I really didn't know for sure what the length was going to be until I got it all mocked up. And it looks like that 4 inches is just about 10 millimeters too long, or about 3/8. Now, I made the error of going ahead and cutting this out before I took that measurement. So now this is not going to be quite centered, but it'll still be fine because this is flush with this, and then this will be flush with the stepper mount, because this recess is actually 3/8 of an inch deep. So it'll just be about like sitting like that. As it sits right now, what I did was I put it all together, and then I measured straight down like so to the center of that coupling to this bottom here, and that's 100 millimeters. And I know that where the bearing sits and this right here is 18 millimeters, so I subtract that from 100, and I get 82 millimeters. Now the distance between where the bearing sits on the ball screw and the end of the ball screw is 70 millimeters. So that's 12 millimeters. That's going to give me a 12 millimeter gap right there. So what I'm going to do is, if I take 10 millimeters off of this, then that'll leave me with just a 2 millimeter gap in there. and that should be sufficient. Now you're going to have to do this on each axis, because I think the Z is going to be, the Y axis is a little bit different, and the Z axis, the shaft is a little bit different, so the coupling may be a little longer or shorter. So depending on what couplings you get, you're just going to have to tweak this dimension right here, but do as I did and cut it a little long. Save this until you get this measurement set just right. So what I'm going to do now is I'm going to go trim this off in the mill, take 10 millimeters off of it, and then we'll come back. Alright, so I've taken, bandsawed a 1/4 inch off, put it back in the mill, and then took it down to 10 millimeters. The total width of this spacer now for the X is 90 millimeters. And when it's all together now, it looks like it's going to work just fine. Okay, so now that I have that adjusted, when you do this, you can just make this 10 millimeters shorter. But you can see we're still going to have clearance there to bolt up our stepper mount, which is what we're going to do next. And we'll probably just use these same screws. So we'll just drill 4 holes. I'll do it with this clamp together, and then just like what I did with this, and then tap it. So now let me get that set up and we'll do that. Okay, so I've got the stepper mount kind of taped in place just to keep it there. It's clamped in the vise. I couldn't turn it 90 degrees because it's too wide to fit in the vise. This is only the 4-inch vise, but it should be okay. We're just going to center drill, and then I'm going to drill all the way down at least 15 millimeters for the threads, and then we'll come back and just drill through the spacer for a through hole. So let's get that done. One thing I want to point out is, because we manually machined this whole mount, not everything's going to be lined up perfect. So do yourself a favor and somehow mark, I don't know if you can see that, but somehow mark the end. This is top and it says X, because I'm going to have a Z stepper that's going to look just like this. And that way you know which orientation it goes, and all your holes will line up. Alright, well, we've got the motor mounted onto the stepper mount. Everything's bolted together. You can see how the X-axis is going to look. I think it all turned out really well. So that wraps up our X-axis stepper mount. I still need to make the spacer that goes in between the bearings for the ball screws, and I'll do that and kind of get it mocked up just to make sure everything checks out. We still need to make the coupling that connects the ball nut to the saddle, but I don't want to do that until I get all the mounts made. I'm going to have to disassemble the mill to do that, so I want to make sure I get all my mounts made. So in the next video, we'll work on our Y-axis. Please feel free to ask questions, make suggestions, and leave comments. Thanks for watching. Please subscribe, and most importantly, be safe.